Welcome to the Geography Paper 1 live stream. So this is part 1 of 2. Obviously, the second one is going to be on the night before the exam. Now, how this is going to work is we're going to cover the first half of the topics today, and then the second half of the topics on the Thursday evening. So we've got 6 topics in each one. You've got natural hazards, tectonic hazards, weather hazards, climate change, ecosystems, and tropical rainforests. Okay. And how are we going to revise this? Well, what we're going to do is we're going to go through exam questions, and that is going to help go through all of the key topics that you should be aware of. Okay, so if you have any questions, do put them in the chat, but I don't see them because the chat often is a bit slower on my replay than it is on your guys's. It's going to end at 7:45, so it's going to be an hour and a half long. So we'll be going through the 6 topics in that hour and a half window. Okay, so let's begin by going through the questions. We are on the first topic, which is not hot deserts, it's actually natural hazards. Okay, so let's begin. Firstly, studying the diagram below. This is mainly for AQA, by the way, these sort of questions. Studying the diagram below, it shows 2 different plate margins. So firstly, what is a plate margin? Can you define this? Well, a plate margin is effectively the boundary where 2 different slabs of the Earth's crust meets. So it could be the meeting of crust of the same type or of different types. So there is the definition. So, and you obviously have 2 different types of plates. You have continental and oceanic. Now they have different densities, and that affects what happens when they collide or they undergo any sort of hitting each other. So describe the difference between destructive and constructive plate margins. So a constructive plate margin is when you've got 2 plates that are moving apart. So this is the first one on the left here. You've got 2 plates that are moving apart, constructive. And the reason why it's called constructive is this then leads to the magma rising and forming what we call a composite volcano. Now, on the other hand, we've got a destructive, which is when they're colliding at each other. Now, because of the different densities, what's going to happen is one of the plates is going to one of the plates is going to go underneath another plate. Okay, and that will then cause earthquakes and volcanoes. So I'm going to write the mark scheme for this question. Here it is. And those are the main differences. Now, also you need to talk about how constructive and destructive, they both can lead to both earthquakes and volcanoes. So how can constructives lead to earthquakes? Well, because they pull apart from each other, that means that they could actually collide into other plates, which means that there's also destructive boundaries formed because of that. And the same thing with destructive, because they're colliding with each other, they can often get stuck and there can be a lot of friction. And then what happens is once that tension is released, that will cause shock waves known as the earthquake. Okay, the next question, describe the characteristics of oceanic crust. So what they're asking you here is to effectively talk about how much do you actually know about the differences between oceanic and continental. So oceanic crust is actually much newer. You don't have to know this, but it's much newer than continental. So oceanic crust is very dense and sinks beneath continental crust. Oceanic crust can be renewed as constructive plate margins and destroyed at subduction zones. So what do we mean by subduction? Well, subduction is just the point at which you can see here the plate slides underneath the other one, the more dense one. So the oceanic plate is going to be subducted by the continental. Okay. So those are the things you can say. So you can talk about the densities, you can talk about the time period if you learnt about that, and you can talk about, because it's more dense, it's which one is going to be subducted by the other. I do not do history, unfortunately. I do other subjects, but I don't do history. So okay, now moving on to the next one. Study the world map below showing plate margins and active volcanoes. So hopefully in GCSE geography classes, you would be familiar with this map or you've seen it at least before. So you've got the lines which are showing all of the plate margins. And what's happening is you've got, well, this particular map shows whether it's a constructive or just a destructive. And then you've got active volcanoes where all the dots are. Now you can see most of the dots lie quite close to the plate margins, but some of them are just in random spots that are not anywhere near plate boundaries, and we call those hot spots. Okay, and that's all you need to know about them. Yes, subduction zone is only at a destructive plate boundary. Really good question. Okay. Now, using the map above, which one of the following statements is true? So, all active volcanoes occur in lines along plate margins. We just spoke about that. No, there's hotspots that exist. There are more active volcanoes along constructive margins and destructive margins. Well, let's look at it. No, because you can see here, these are all constructive, and there's not many volcanoes here. But on these ones, which are destructive, there's lots of volcanoes forming. So, no. C. There are many active volcanoes around the edge of the Pacific Ocean. So let's look at this. Edge of Pacific Ocean. Yeah, it seems true because there's lots of active volcanoes. Let's just look at the next one. Active volcanoes are found along the eastern side of North and South America. And no, that is not true. So it's going to be C. Okay, we're now going to look at the next part. Describe the movement of plates along plate margin X. So let's see, what is plate margin X? You can see this is destructive. So they're asking you to describe how plates move along destructive boundaries, and all you have to say is that plates are colliding together. Plates move towards each other or they collide together. Okay, now on to tropical storms. So, describe the conditions that lead to the formation of tropical revolving storms. So, there's loads of different ones you can say. You can say the temperature of the ocean needs to be above 26.5 degrees, or you can say 27 degrees. It needs to be in summer where the seas are the warmest. It needs to be at latitude between 5 degrees north and south of the equator. Or you can say it needs to be in areas where there is a lot of wind so that the spin can develop, and yeah, any of those sorts of answers would be completely fine because there's only one marker there. So just asking you to kind of blurt something out. Okay, next. Study the map showing the track of Hurricane Irma in September 2017. So you can see the path that it went along before it hit land. Now, another common idea here is, why doesn't it keep going? Why does it kind of dissipate as it reaches the land? Well, it's getting all of its energy from the ocean. So once it makes landfall, once it touches the land, it's not got that resource, it's not got that energy resource, so it eventually dissipates. And that's why coastal areas are more affected. Okay. Now, using the map above, describe the track of the hurricane between the 6th of September 2017 and the 12th of September. So describing it. So you can say that all you have to say is you get any mark for talking about the direction and how it's changing. So you could say the hurricane had a change of direction initially, its movement in the northwest direction, or you can say it passes over the north of Puerto Rico. So it's mainly asking you for your compass skills. Okay, so your main answer will be northwest. Using the map above, what happened to the wind speed of the hurricane between 8th and 12th of September? So let's look at that now. So between the 8th and the 12th, so between here and right up until the end, what about the wind speed they're asking you? So clearly you can see that the wind reduced, and that's because if you look at the colors, it's going from a deep red to lighter colors, and the key told us that means that the wind speed is being reduced. So clearly it's being reduced. So it's all about just saying what you see. And geography is a really nice subject like that. It's effectively talking about writing what you see and taking note of the obvious. Okay, study the photograph showing the effects of Hurricane Matthew in southwestern Haiti. Now, the most common error in geography papers when you've got a question like this is people not referring to the figure. Now, you're supposed to refer to the figure when answering questions like the 8 markers, because you want to talk about, okay, you can see there's a lot of destruction that's happened here. The houses aren't really clearly sturdy quality, and therefore they're very susceptible to damage. So always refer to the figure, because otherwise you won't be able to get that full 8 marks. So using the photograph, state 2 primary effects of Hurricane Matthew. So firstly, knowing what is a primary effect? Well, it's something that happens immediately after a disaster has occurred. So looking at this photograph, what can we see? Well, we can see that the roofs of many houses were blown away. That would be a primary effect. Something else we can see is that there's a lot of damage to buildings. You can then make the inference that many people are homeless, and there's damage to pathways, there's damage to roads. So any of those answers will be completely fine. This slide is good because we're going through the content, but also going through exam skills, which are really important. Okay, what is global climate change? Now, when you're answering this, well, they specifically said global, so you need to mention global in your answer. You want to say the worldwide change of temperatures because of the increasing or decreasing temperatures, or the rainfall patterns, or anything like that. So as long as you're talking about both of those factors. Now, study the diagram showing the process of global warming, a cause of climate change. So you've got a diagram given to you here. Identify 2 sources of greenhouse gases suggested by the diagram. This is quite straightforward, so we're just going to go moving on to the next question because we want to get quite a lot done today. So here is a graph showing the amount of carbon dioxide released into the atmosphere. Describe the change in the amount of carbon dioxide in the atmosphere shown in the graph. So what you want to talk about here is looking at it clearly increasing over time. And from 1950, perhaps the Industrial Revolution fueled a lot of carbon dioxide being produced. So that there was an exponential increase from there. Before it was a steadier increase, but then there was a sharp incline at that time. So there's a mark for getting that, which is really important. You can also talk about other things such as deforestation and possibly give reasons for it. When they're asking for describe, they want you to talk a lot about reasoning. Explain how volcanic activity and orbital changes may cause long-term climate change. So we actually spoke about this in the previous AQA Geography revision live, but we can go through it again. So understanding that volcanic activity, or that releases plumes of smoke, and that can actually lead to global cooling because it's covering the Earth's atmosphere, so solar radiation cannot get through, so it means that the temperature of the Earth is a lot cooler. On the other hand, volcanic activity releases a lot of greenhouse gases, which will only contribute to global warming. So it has 2 very different effects. And then talking about orbital changes, so looking at the shape of the orbit of the Earth, whether it's elliptical, also looking at the distance between the Sun and the Earth, looking at what kind of season you're in as well, all of those things you want to discuss. Okay. And that is it for this topic. So we're now on to tectonic hazards, which we actually spoke about a little bit in this document. So get some extra practice. Now, this specifically, which I'm going to show you now, is a typical question which comes up. They give you here. So study figure 2, photographs showing different types of responses to tectonic hazards, because in the first example that you've learnt, it's all about looking at the difference in responses between a high-income country and a low-income country. So whether you learn about Nepal or New Zealand or Italy or anything like that. So we've got the immediate responses to a tectonic hazard in Haiti. So what can we see here? There's resources. You can see if you're really observant that you've got the Red Cross, the charity, and they're giving all of these resources. So rather than the government providing it, it's international charities. Now, you can see below that you've got a long-term response to tectonic hazards. You've got the building of houses and the construction of them. So, long-term responses to a tectonic hazard are more important than immediate responses. Do you agree? Use the figures. Really important to use the figures, as I spoke about, and you want to talk about your examples, your case study that you have learnt. Now, another key thing to talk about is, do you agree? So because they're saying, do you agree, you don't want to sit on the fence. You want to choose one side or the other. Oh, I'm so sorry the questions aren't visible. Thank you for saying that. Oh, I'm so sorry. I spoke a lot about that. Okay. So let's explain our answer. Let's talk about things that we can now say. Sorry, I'll show you the pictures because you clearly didn't see them. So you got the first one, which is immediate responses to a tectonic hazard. You got the Red Cross. The second one, which is long-term responses, the construction of houses. The question itself is, long-term responses to a tectonic hazard are more important than immediate responses. So you can put in the chat which actual example you learned. Did you learn the Nepal versus New Zealand, or did you learn another one? I do have a video going through all of the case studies and examples. So you don't have to talk about Haiti, you just have to talk about the images given and the figures. So what is shown in that, and that's the maximum that you're going to have to speak about this. Okay, so now let's look at some ideas that we can possibly discuss. So we're looking at responses. Notice that as well, not primary effects, not secondary effects. So a lot of you learned about Japan, which is interesting as well. So I'm just going to get Google Docs up so we can kind of plan the answer to this 9 marker so that you're prepared for some bullet points as to what you can say if you were given it. And even though they've asked this question before, they definitely can re-ask this question. So let's see what kind of things we can put in our plan. So firstly, we want to make sure that we're referencing the figures. So what do the figures show? Well, we can see that the first figure, the immediate response, is the initial aid. It's giving food and resources. So we can put here that the immediate response provides aid, food, resources. This can prevent unnecessary loss of life from things like starvation or not being able to access those resources. And another thing is, if it was also the medicine, then it will prevent the spread of diseases. as well. So immediate responses are important in that respect because loss of human life, you could argue, is the most important factor if you're considering the effects of a natural tectonic hazard. And then we can see here long-term responses to a tectonic hazard, the construction of houses. So how is the construction of houses important? The construction of houses reduces the homeless population, and therefore there's going to be a better standard of living for the individuals who come from the country. So now we've spoken about the figure, let's speak about some points from our example. So if you remember any statistics, then put them in the chat below. Okay, so let's now speak about some points that we've learned about. So why would immediate responses be more important, or why would long-term responses be more important? And also pick a side as well. So immediate responses, what kind of immediate responses might you have? So things like sending out warnings, constructing emergency shelters, evacuations of vulnerable people. I remember that in New Zealand, they evacuated the most vulnerable 200 people and families, and that actually prevented their lives being lost because obviously they won't be able to escape themselves. The restoration of power being restored, but sometimes that actually counts as a long-term response because it takes a lot of time to reconstruct all of those things. Really good examples there. So rescue teams, evacuation, well done. Now looking at long-term responses and how some of those might be more important. So long-term responses, you've literally got things like reinvesting in tourism, because tourism is often a way for the low-income countries to accumulate more money, accumulate funds to then fund the rebuilding and construction. The building of roads, restoring things like water supply. In the Nepal example, water supply was restored 2 years after the tectonic hazard, and water and food, these are the basics for people to have access to. So that's really important as well. So now let's think about some evaluative points we can make, or comparative points. How do we say that long term are more important than immediate? Well, immediate, we clearly see prevents the loss of life initially, and it gives people some resources in the short run at the beginning. However, in the long run, you can see the construction of houses, all of the long run effects are more important for sustaining the economy of a country, whereas the short term seem to be sustaining the lives of individuals. So since we have more points for the immediate responses, you might want to say that immediate responses are more important. The examiner won't necessarily get angry if you keep talking about the multiplier effect, but you want to not mention it too many times because you want to show that you've got different points. Resistant buildings, Japan. So that's more of a precaution, having resistant buildings. Or I guess you could argue it's a long-term response if they put it in after having a tectonic hazard. So yeah, that's a really good one for long-term. So you could argue either way. Whichever one you believe in, you have more points in, I recommend doing that. And definitely using statistics as well. It's really important as well when you're referencing your example, you don't just say in Nepal, you have to name your example. Okay, naming your example gets you a mark, but then they want you to name it correctly. Tell me the year, tell me the place it happened, tell me what type of tectonic hazard or natural disaster occurred. Okay, you need to be quite obvious. Yeah, the cost of rebuilding, that's a good point as well. Okay. Let's now go back to the question sheet. So, this shows a map of the distribution of earthquakes in and around Japan. This is ironic because a lot of you were talking about Japan, which is really useful. So, using figure 4, which one of the following statements is true? There's a lot of multiple choice as well. And another tip is for geography, a lot of the multiple choice is actually found at the bottom of pages, and a lot of people miss them. So make sure you look at the bottom of each page to and show that you're answering all the questions. Okay, so which one of the following statements is true? Firstly, most of the stronger earthquakes happened on land. So let's go back to the map. Well, you can see the stronger earthquakes are represented by larger circles. Now, you can see most of these, the strong ones, actually happened in the ocean, so not really, that's false. B, most earthquakes happened to the east and southeast of Japan. Well, we can see the east and the southeast. Yeah, that seems about true, actually. So B seems right, but let's just make sure that C and D are incorrect. So C, most earthquakes around Japan were over 7 on the Richter scale. No, you can see a lot of smaller ones, so that's not true. And D, no earthquake greater than 5 happened to the west of Japan. So never eat shredded wheat, you've got west, and here you can see that there's actually some quite bigger ones here, so that's actually false. So B is your answer. Yep, the computer science live stream was J277. That's true. Okay, now looking at the next one. Using figure 4, name the type of plate margin between the Pacific and Eurasian plate boundaries. Okay, so where is it? Going back to that. Oh. So the Pacific and the Eurasian, what type of plate boundary is that? Well, you can see by the arrow, so the Eurasian plate is being pointed this way, the Pacific is being pointed that way. Since they're coming at each other, then that means that they're colliding, and therefore it's going to be destructive, or another word for it is convergent. Okay, moving on to the next one. Suggest one other tectonic hazard that is likely to occur next to the plate margins shown. So you can talk about, well, obviously it's given that there's earthquakes, so you can say volcanoes, tsunamis, anything like that. Keynote here, you're not going to be credited if you say hurricane or the other one which I've forgotten, but if you say hurricane, it won't be credited. Typhoon, sorry. So hurricanes, typhoons, they won't be accredited because tsunami is the correct term for that. Okay, moving on. A map showing the tectonic plates in and around North America and South America. Okay, so we've got more maps here. Using figure 2, explain which of the following statements is true. Shade the one circle only. So firstly, we've got that the Nazca plate is moving towards the Pacific plate. No, that's not true. They're going in opposite directions. B, earthquakes are found in long, narrow zones along plate margins. Yeah, it seems like that because look, the earthquakes are shaded areas of this, so they seem to be happening across the plate margins. C, earthquakes are mainly found along the eastern side of continents. No, they seem to be happening all over. D, the North American plate is moving away from the Pacific plate. No, they're moving side by side in the same direction. Yes, landslides are a good and important thing to say as well, actually. Well done. Well done for everyone who's actually interacting and engaging. That's really impressive. Okay, using figure 2, name the type of plate margins. We've answered similar questions to this. 4C, suggest why earthquakes and volcanic eruptions happen close to plate margins. Use figure 2 and your own understanding. So why do they happen? Well, keyword here is suggest. So they want you to talk about, i.e., how do destructive plate margins cause how do plate margins that are destructive coming at each other cause volcanoes to happen, and destructive volcanoes to form? So it's actually crazy how schools teach this in very different depths. Some schools go into the whole process and talk about slab pull and things like that. Some, however, talk about other processes as well. So what you can say is that there's a gravitational movement of plates, and the denser oceanic plate is going to be sinking into the mantle beneath the continental plate boundary. It will be subducted under the influence of gravity because it's more denser, so it's going to be pulled, and that's slab pull. And then what's going to happen is that there's going to be a subduction zone because of the two plates hitting at each other, and the denser one is going to have to fold and go inwards and be subducted. That plate then melts, and as that plate melts, it then forms a magma pool, and that magma pool is then used to fuel a volcano that forms. So that's how volcanoes form at destructive margins. Now, how earthquakes form at destructive margins. So what happens is as it's subducting, as it's sliding against it, what happens is it can get stuck, and then as it's got a lot of tension as it gets stuck, and then once it finally pushes past it, it releases a lot of energy as shock waves. Those shock waves pass through the entire plate, and they can cause earthquakes to occur. Yes, you can speak about convection currents as well, but they are not required too much in AQA, but they're definitely worth talking about. Okay, let's now move on to the 6 mark. I know some people want to just do the higher mark questions, so maybe we'll focus more on those as a live stream. We're getting a little bit short of time. So, explain how living in areas that are at risk from a tectonic hazard may be both advantageous and disadvantageous. So, let's think of some advantages of living in areas that are at risk of tectonic hazards. Well, things that can happen examples are there being very fertile soil. So areas where you've got volcanoes, what happens is a lot of the magma that then flows down and forms like lava when it's finally released the volcano. So once it actually interacts with the soils, it gives a lot of natural nutrients, and that means that there's a lot of fertility for the soil, and therefore this can lead to agriculture or any sort of other developments. Now, another natural resource that's really good with things like volcanoes is diamonds. You can get really large diamonds both inside and outside the volcano, so they are quite useful. Now, some people are saying tourism as well. Tourism is a good one as well for places like Hawaii. They rely on the volcanic tourism to support their economy. Now, advantages also, your family is there, because sometimes you don't want to have to move away from your whole family just because of a tectonic hazard. And most of your family might reside there, and it's just difficult to move. Another thing is that the tectonic hazard might not be alive. Not alive when active. It might not be active. For example, some parts of Italy live really close to volcanoes, but they're not active, so it's not actually a threat. Now, disadvantages, or another advantage is that there might just be technology, which means like really high technology. For example, Japan, they have really high technology which allows them to cope really well. Disadvantages, there's probably loads, loss of life, loss of livelihoods, or loss of jobs, loss of homes. There's just endless disadvantages as well. And obviously that the value of the house is not very high either. This is for AQA, so it's not for EdXR. Okay, moving on. Suggest 2 ways that planning might help to reduce the damaging effects of an earthquake or a volcanic eruption. So, things you can say is practicing earthquake or volcano drills, planning evacuation routes, having a stockpile of clean water and food, educating people so they know what to do if an earthquake happens, you know the exact procedure, and also preparing hazard maps to show where there'll be the highest risk of damage in what areas that you go to. So you want to go to areas that are away from really high buildings. Okay, moving on. Here's a map of Iceland, which shows tectonic plates. Okay, we've done a lot of map questions, so let us move on to the next topic, which is weather hazards. So I hope you're finding this useful. At least maybe we'll focus now on more higher mark questions, as that might be more beneficial for you guys. And another thing to keep in mind is some of the topics that haven't come up in a long while, they actually sometimes do randomly pop up. So don't rely on the past papers too much as and where to look for your predictions. Okay, so here we're looking at weather hazard questions now. So we've got the global patterns of air pressure and surface winds, so the global atmospheric circulation sort of diagram there. Using figure 3, which one of the following statements is true? Air sinks at the equator. That's false. Air rises at the equator. The southeast trade winds blow from the equator to 30 degrees north and south. So let's look at the diagram. Nope, that is incorrect. C, high pressure occurs when the air is sinking. We know that's true. There's high pressure when air sinks and low pressure when air rises. So C is the correct answer. Okay, let's now look for some higher marked questions so that you guys can practice. Okay, here's a good one. So, study figure 3, information about Cyclone Idy and its impact on Mozambique. And then the question is, suggest why some tropical storms have severe primary and secondary effects. So let's quickly look at the figures that are provided. So this is question 6. Okay. So the question is looking at why there are severe primary and secondary effects. So again, what is the difference between primary and secondary effects? We spoke about this already. Primary is immediately after, and secondary is caused by something else. For example, landslides or tsunamis that are caused by something happening initially. So primary effects that we can kind of see. We can see the destruction of homes, probably the loss of life, transport and communication lines not working, homes being destroyed, damages to infrastructure, trees being uprooted, storm surges happening which cause flood barriers to break. Those are examples of primary effects. Now, secondary effects include people being homeless, left homeless, waterborne diseases causing spread of diseases, looting and other crimes starting to happen as people become desperate and they do antisocial behavior. A lot of insurance claims which could cause banks to become bankrupt. the destruction of crops, which could eventually lead to malnutrition and starvation, disruption of coastal habitats, as well as salt water mixes with fresh water that could have really damaging impacts on organisms that rely on those, mudslides, landslides, etc. So those are examples of primary and secondary effects, but we're asked about why some tropical storms have severe ones. Okay, so how you could possibly answer that is looking at the severity of the primary and secondary effects are dependent on either planning, protection, or other things, or you can talk about the development of a country and therefore give your examples that you've learnt about. So, looking at your tropical storms, did you look at Typhoon Haiyan? And maybe you looked at some other examples and talk about how the development of the countries impact the amount of resources and the quality of resources that they allocate to certain funds, and therefore, for example, the houses might not be made of good quality in low income countries, and therefore they're more susceptible to being broken down and destroyed. Yes, exactly. High income countries have much better technology. So Japan is a good example of that. Okay, and I believe the rest of these questions are quite low marking, so that is it for weather hazards. And we're now going to move on to the next topic, which is climate change. Now, I've never really seen too many questions on climate change, but it's always good to see if we can do a practice. Often there's questions on the causes of climate change, like we spoke about orbital and volcanic causes. So let's see what we could possibly look at. Okay, here is a good 9-mark question that we can do. I would show model answers, but I don't think there's enough time in this live stream to. I think in the night before live stream, I'll prepare a 9-marker for you guys to possibly look at. But they don't care too much about the structure. It's much different compared to like RS, where they care about the structure. Here it's more about just getting all your points across, your 4 points and your against points. Okay, so we're now going to look at this 9-mark climate change question. So we've got photographs showing some causes of climate change. To what extent is climate change the result of human action? So that's an interesting question. Let us do a sort of plan or output of different points that we can make. So firstly, we need to always refer to the figure. So what can we see in the first image? We can see a lot of pollution, from manufacturing industries, and you can talk about globalization, trade, all of those sorts of things, which lead to pollution, the production of greenhouse gases, and those therefore cause global warming. So that is a human cause, and that impacts it. That's a sort of chain of reasoning as to how that occurs. Now, on top of that, we can talk about the use of fossil fuels as opposed to using more renewable sources. So we tend to rely on fossil fuels because the amount of energy generated from them is a lot. They're quite powerful compared to renewable. Also, they're currently much cheaper, but obviously as they become more scarce, they're going to be much more expensive. On top of this, let's look at other things that impact that. So on top of, manufacturing, globalization, what else are fossil fuels used for? Fossil fuels are used for heating. It's used for transportation. So it's used by households as well as these big corporations and businesses. Now we need to think about other factors. So not just this human factor, but other things. So we can talk about heavy agriculture, how heavy farming, heavy industry farming. For example, we've got in the Amazon rainforest, there's a lot of farming of cows because they've got a huge beef sector and also milk, but they release a lot of methane. And on top of that, they cause depleting resources for trees and things that photosynthesize because obviously they're eating them, and therefore that's just reducing the amount of carbon dioxide being reabsorbed. So there's agriculture. On top of this, we have forest cover, so deforestation. It's quite an obvious one, actually. That is directly linked to that because of the reduction of trees and things that are able to, again, absorb carbon dioxide. So those are all the human factors. Now let's talk about the natural factors. You can see volcanic activity there. So how does volcanic activity lead to climate change? Well, we spoke about it leading to global dimming or global cooling, because obviously the smoke that's being produced reduces the amount of solar radiation received. But on top of that, the smoke being produced actually reduces the amount of light that certain areas are receiving. So it seems quite dark in those areas sometimes when there's been a recent volcanic eruption. So volcanic activity can impact that. And also it can cause global warming because of the production of the greenhouse gases and sulfur dioxide, etc. Now, on top of this, what are the natural factors? Well, we've got orbital changes in the Earth's orbit that impacts the amount of sun and solar radiation that we're receiving. Ash in the atmosphere creates a cover over the Earth, trapping warmth inside. That's a really good analysis point as well. Okay, and also, another natural factor is the cycle that we're in. So whether we're in the quaternary cycle or another period, so you've got the different Milankovitch cycles as well of the Earth wobbling, but you've got the cycles of the different, whether we're in the Ice Age or the warmer periods, because there's actually a graph which tracks how it's very cyclical and predictable, and that impacts how much solar radiation we're receiving. Okay, so those are the different points that you can make there. Yeah, Milankovitch cycles are deeper knowledge. You don't necessarily have to know too much of that. Okay, we're now going to move on to the next one, which is ecosystems. And then we'll go through tropical rainforests. I hope you guys are finding this live stream helpful. I know there's a lot less of you here, but that's probably because maybe it's the weekend, so you're preoccupied with your own revision plan. But that's completely fine. Well done for being here, and I hope you'll find it useful. If you want me to change anything, I can also do that to make it more applicable to you. Okay. Let's now move on to the questions about ecosystems. So this depends on which sort of ecosystem, small scale ecosystem that you learnt about. But also knowledge on global ecosystems is important as well. So the different tundras, etc. So the different layers of them and how that links to how far you are from the equator. So let's look at this question here. So here we've got a food web showing a small scale ecosystem in the UK. Now, using this figure, which one of the following statements is true? So sparrowhawks eat plants. Nope, they eat small birds. Voles eat moles. Nope, they do not. Moles eat beetles. Yes, they do. Clearly, that arrow is showing that. So the answer is C. let's find a higher mark question to do some practice with. I think that'll be beneficial. There's a lot of biology crossover here. Okay, there's not actually many questions. These just typically tend to be 1 markers and 2 markers. So here's a good question, a calculation question. So try and do this one actually. Study this figure, a graph showing the biomass of different levels in the food chain. So you've got sparrowhawk, which is a tertiary consumer, small birds, secondary consumer, caterpillars primary, and deciduous tree leaves are primary producers. So calculate the percentage loss in biomass between the primary consumer and the secondary consumer. So 1200 to 300, what is the percentage change or the percentage loss? So try and calculate this, and I'll reveal the answer in a short second. I mean, just looking at it, predicting, well, if we're going from 12,000 to 300, clearly it's been a massive jump. It's not 2.5%, and it's probably not 25%. So let's see which of the two it is. So hopefully that's been enough time for you guys to possibly answer them, or maybe you're answering them in your own time. That's completely fine. So the answer is B, which is 97.5%. Okay. Yeah, there's not too much on ecosystems. I guess we'll look more at tropical rainforests then. So here we've got 2 photographs of different parts of a tropical rainforest. Using these images and your own understanding, explain how development in tropical rainforests, tropical box rainforests, creates economic advantages, but at a cost to the environment. Tropical rainforest, just common sense. It's mostly common sense. However, if you're thinking about the case study, that is a lot of facts and memorization. Yes, so people are saying mining, people are saying deforestation, people are saying tourism. Yep, you only need to refer to the figure once. But you want to refer to both photos, so you probably need to refer to it twice if you're making 2 separate points there. So, economic advantages. So as people have been saying, mining, farming, energy, these all lead to jobs such as construction, farming. Now, companies pay taxes, the public services such as education and water supply are removed. So these are all the economic advantages. The standard of living is improved. You have greater access to educating, which means greater career possibilities. Now, how does this all happen? What are the disadvantages? Well, forests are cleared to make space for things like cattle grazing, which happens a lot in the Amazon rainforest. So these large companies make profit. There's improved transport, which opens up areas for industrial development. Hydroelectric power, that also is another use of forests. You can talk about ecotourism, and you can talk about ecotourism how as an evaluative point. So because we're talking about how development causes issues to the environment, and ecotourism is kind of a solution to that. So you can definitely mention that, but it depends. If this is a 9, see, if it was a 9 marker, you would want to talk about ecotourism. But since it's simply a 6 marker, I feel like they want you to just focus on explaining the development and how that leads to it. So I'm just making some points here. We've got mining, cattle grazing, roads and hydroelectric power, and energy. So those are the main things that and you can talk about tourism as well. But tourism, again, yeah. So any of these points, they typically have positive economic effects, and you can speak about them generally: improving standard of living, improving education, improving resources, improving housing, etc. And then the disadvantages you'll talk about to the environment. So for example, mining, the explosives that are used in mining are very hazardous to the environment, and that can actually cause some parts of the environment to completely degrade and never be used again. Cattle grazing, again, it causes a lot of soil erosion, which reduces the rainforest cover over time. It also releases a lot of methane, which contributes to global warming, again, a cost to the environment. A reduced carbon sink as well is highly impactful. Okay, roads, the construction of roads. Again, this ruins the ecosystem. And a key point that you want to make is the heavy interdependence in ecosystems. So there's not just interdependence in ecosystems, but there's a lot of interdependence in rainforests and the Amazon rainforest, which means that every living thing depends on the population of another living thing. And the reason why is because as we're deforesting more and more and more, the number of different organisms are reducing. So they're relying on less and less things. And if they're relying on less and less things, then one impact can have a huge effect on the entire population and shift that. Yes, exactly. Using your own knowledge is important as well. So you'll use your knowledge from the Amazon case study, or if you looked at the Malaysian rainforest, it depends which one you've looked at, and you can speak about those in more depth there. Only a 6 marker though, so not too heavily. You don't have to evaluate. Okay, so this is another thing that people often forget to revise. Which part of the rainforest matches the following description? An almost continuous layer of branches and leaves between 15 and 30 meters high. So what is that talking about? Well, if we're looking here, you can see between 15 and 30 meters high. So that is actually referred to as the upper canopy. The emergent canopy are the ones right at the top, and then you've got the lower canopy, which is probably between 15 to 20, and then the understory, which is right at the bottom. So yeah, well done for those answering B. Describe one characteristic of the base of the taller trees. This actually came up in the exam I think last year. So what characteristic of the base of the taller trees? What would you say? Well, hopefully you use the key term buttress roots. That's really important to mention. So buttress roots basically means that you have a wider base than the rest of the trunk. And that wider base helps to really keep it in the ground. It anchors it. Well done for those saying buttress roots. That's amazing. That's exactly the terms that you needed to mention. Okay, so here's a newspaper article about wildfires in Brazil in August 2019. Give one feature of the patterns of wildfires in Brazil. So what kind of assumptions can we make? Well, you can see that they are concentrated largely in the central regions of Brazil, but here they want you to talk about, they normally, when they're giving you one mark and they give you a map, they are testing your map skills, your north-south, your compass direction skills. So you can talk about how they're mostly concentrated in the northern parts of Brazil rather than the southern parts. There are relatively few in coastal areas. That's another thing you can make. Central Brazil, exactly, central or north. Buttress roots and shallow roots. Yes, there can be two separate adaptations. That's correct. Yes, so any of those points. Central Brazil or northern Brazil, they both get points. Outline one reason why wildfires are a threat to the global climate. So hopefully this is a bit more obvious. Well, wildfires are impactful because obviously the Amazon rainforest, that's a huge carbon sink because we're talking about Brazil. So if the trees are destroyed, the carbon sink is lost. And then on top of that, that wildfire is releasing lots of carbon dioxide itself. So it's not only destroying the source of oxygen, it's creating one as well. Exactly. Well done for those answering in the chat. Okay, so this is just a calculation one. Hopefully you should just be able to add them up and divide them by how many there are for the mean. Oh, okay. Question 5 here. Outline, I don't know why that's 5 marks. I think that's a mistake. It's supposed to be 1 mark. One reason for the distribution of a tropical rainforest. I think that's not clear. I think that's a mistaken question because the distribution of what? Okay. That question I think is a mistake. Okay, and yeah, there's not too many left. So that's tropical rainforest. Let's move on to the next topic, which is hot deserts. Oh yeah, at the equator, that makes sense, yeah. The distribution of tropical rainforests, I think they're between 5 and 25 degrees north and south of the equator. Yeah, because air rises, they're hotter. Well done. That's very true. Okay, so we've done natural hazards, tectonic hazards, weather hazards, climate change, ecosystem, and tropical rainforest. Okay, so that actually marks all of the practice questions that we're going through today. Hopefully that's helped you revise. Cold environments we'll be doing in the Thursday live, do not worry. But that's all we're doing in this live because we have to get on to French. I mean, French is starting in 30 minutes. Maybe I'll make that a bit earlier. But I hope you found this helpful. It hopefully made you revise some of the topics and practice some exam skills. And yes, okay, so thank you for coming. It means a lot. And I guess I will see you in a future live stream. We're doing lots of English literature ones tomorrow, which should be very helpful to you guys because they'll have actual grade 9 essays in them. Okay, so yeah, exactly. Thank you so much, and I will see you soon. Good luck.